Let's evaluate some square root here. We have h of x equals negative square root of 4x plus 5. And we're asked to evaluate h of 1, h of 10, and h of 1/8. So they're asking us to find the y partner when x equals each of these numbers. And we do it the same way we always have. We just plug it into the expression in place of x, and we use parentheses just to keep ourselves honest, make sure we don't make a mistake. H of 1 is a negative square root of 4 times 1 plus 5, so it's negative square root of 4 plus 5, which is negative square root of 9. So evaluate the square root of 9, that's 3, so we have negative 3 for our answer. You'll notice that the negative sign was just a hitchhiker on the outside. It had nothing to do with the problem. It just came along every step of the way. It was out in the front. Now we're going to evaluate h of 10. That's equal to negative square root 4 times 10 plus 5, negative square root 40 plus 5, negative square root of 45. Okay, now you ask yourself, is there a perfect square factor embedded in 45 that we can factor out and bust out of the radical? And the answer is yes, there's 9. 9's a perfect square, so that's equal to negative square root of 9 times square root of 5. See, I broke it apart multiplicatively. Now evaluate the perfect square root. The square root of 9 is 3, so the negative sign comes along for the ride. 3 times the square root of 5, and that's the best as we can do. We can't get anything more out of the radical, so we're finished. And then the most interesting one is h of 1/8. That's equal to negative square root 4 times 1/8 plus 5. Now you know how to multiply fractions. We get negative square root top times top over bottom times bottom. So it's 4 times 1 over 1 times 8 is 4 over 8 plus the 5. But we can simplify 4/8. We can cancel a 4 out of the top and bottom. So we get negative square root 1/2 plus 5. Now, we want to see if we can simplify this radical. But before we can even ask that question, we need to get a single term and see if we can factor any perfect squares out of it. So we're going to add these two numbers together. Now, if we're going to add a fraction, we have to make sure we have a common denominator. So that's our next job, get a common denominator so we can add these two fractions. They'll be fractions then. Okay, we're going to get a common denominator, which will be 2, of course, because that's our only denominator. So we have negative square root of 1/2 plus, okay, multiply 5 top and bottom by 2, and we'll get 2 times 5 over 2 times 1. All right, so let's do the addition across the top. 1 plus 10 is 11 over 2. Now, think about this. This problem, this guy is not simplified because this problem has a radical in the bottom, and we never want to leave a radical in the bottom of our fraction. Now, if you can't see it, let me make it really clear. I'll break up this fraction top and bottom. Square root of the top over square root of the bottom. See, now it's really clear to see. I have a radical in the bottom, and I need to get it out. So I'm going to rationalize our denominator. And since there's only a single term in the denominator, nothing's being added or subtracted together, not more than one term there, the method I use is multiplying the top and the bottom by the radical that appears in the bottom. So my original negative square root of 11 over square root of 2 is multiplied by this fancy form of 1 square root of 2 over square root of 2. Now multiply across the top. When I multiply across the top, I can do it under one radical. So equals negative. See the bottom, well, the bottom is just the square root of 2 raised to the second power. And the top is the square root of 11 times 2 under a single radical sign. Now you see we were able to eliminate the radical because the square root and the square are inverse operations. They cancel each other. So I get negative square root of 22 over 2. And now I ask myself, can I factor a perfect square out of 22 and bust it out of the radical? And the answer is no. There's only a 2 times 11 in that, so there's no perfect square factor. That's how I know I'm finished. And there's no radical in the bottom, so I know I'm simplified.